I'm sure by now everyone was aware that we're going to have a session. Right, I've started recording and I've shared my screen. I just need for you to confirm if you see my shared screen.
Yes, I can. I can see the screen.
All right.
I can see the screen, so
Right. So everyone has a question paper. Sorry about that. Everyone has a question paper, right? Hello.
Yes, sir.
Because the first thing I want us to look at is the memo for the first assessment, which perhaps I can open both of these here. Uh, I'll open the question paper as well. Right. So I've opened both the memo and the question paper for our convenience. Right. 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 So let's go through the first question. So the assessment had two questions. The first question is based on precision measurements, and the second question is based on hydraulic systems. Right. As per the assessment plan, precision measurement is 15 marks, and hydraulic systems is 20 marks. Right. So let's first look at the first question. Right, and look at how you should have approached it. Right. So question one, 1.1, calculate the distance x in figure 1 below. So this is the figure we are referring to. Right, figure 1, where we have to calculate the value of x. Right. Now here what I did was I redrew the diagram. It's always much easier if you redraw the diagram and draw all the other small diagrams onto it, hence labeling the bigger diagram as well. Right, it makes it convenient for when having to calculate, say, some of the distances and some of the angles here. Right, it gives us context as your markers as to what exactly you are calculating. Right. Right. So to calculate the distance x, here's the distance x. Right. So which means in order to get the distance x, you must have this whole distance here. Now, of the distance x, we already have this measurement of 125, right? But to make things convenient, I have labeled this here, right? This point is my A, this point is B, that point is C, this point is G, right? And then, of course, from here, remember that the left-hand side is equal to the right-hand side. So the reason why I didn't label this point and then point and this point is because this length here we know is equal to BC, and then this length is equal to AB. Right. By now you should know that. If you took your time trying to understand precision measurement, right? So that is to say that in order to get x, we need to have this distance, which we already have, right? If you look at what this distance is equal to, it is equal to the radius of the roller, right? And here we've been given the diameter, which essentially gives us the radius. So the diameter is 25 millimeters. It means the radius is 12.5. So we have the distance AB, which means we have this distance as well. So the only distance to calculate here is BC, which will inadvertently give us this distance, right? And then of course we have to calculate this distance as well. So in order to get X, you must have calculated this distance, BC, as well as CG. Are we still together here?
Yes,
Yes, sir.
sir.
Right. Now, in having to calculate BC in such problems, right? In having to calculate BC, so this distance in such problems, this is the triangle that you need to draw, right? You draw a line from the center of the roller, right? Drawing a line from the center of the roller to where these two tangents meet. So you have two tangents here, namely AC and EC and AC, right? This is a tangent, that's a tangent. Both of these tangents meet at this point. So where the two tangents meet, right, that is where you draw a line, right, pointing towards or that goes towards the center of the roller. Right? That is how you get this line, right? Thus splitting these two sides in equal portions. Right? So meaning that if this angle, right, if this entire angle, right, is say theta, it means that if this is half of this entire angle, if both of these angles are half of this entire angle, it means that if you have this whole angle, you inadvertently have angle C there on triangle DBC, right? Which, if you look at the diagram we've been given, right, we are told that this angle is 65. So this angle here, right, on the diagram is drawn on this side, but like I said, remember the left hand side is equal to the right hand side unless stipulated otherwise. So which means if this 65 degrees, it means that 65 degrees. So we have this whole angle, and then we know that if drawing a line from where the two tangents meet to the center of the roller, if that's equally splits, right, this angle, it means that this angle is going to be 65 divided by 2, right? Are we still together there?
Yes,
Yes, sir.
sir.
Right. So I'm just mentioning a couple of things that you need to take note of before you even start writing up your solution. Right. These are just the basics of such problems that you need to consider. That in having to calculate BC, you have to calculate that small angle, and that small angle is half of this entire angle. Right. Which means the small angle will be half of 65, seeing that we are given the 65. Right. So we know that is how we are going to attain BC by getting that angle because we already know what dB is equal to. Right? dB is equal to the radius. We have the diameter, so we have the radius. Right? So that's number one. Number two, in having to calculate CG, how are you going to get to calculating CG? You are given this distance, which is 125. Right? We know that again the left hand side is equal to the right hand side. So if you draw this triangle, if you get that distance EF, you will inadvertently get this distance here. Right? So you had two choices here. You could have drawn this triangle on this side or on this side. Either way, that measurement is going to be the same. Right? So again, here you work out your angles. You know that if this is 65 degrees, you can either still use 65 degrees, right? Say that this alternates with this 65 degrees, meaning that this here is also 65 degrees. Or you can work out this small angle here. So the angle C in triangle ECF. Right? So in triangle ECF, the angle C, you can work that out and use that angle in having to calculate the measurement. All right, so you have two choices there. All right, either way, once you've worked out one of the angles, you will have one angle. The person that's so everyone must mute themselves. Ne? Just make sure you have muted yourselves unless you have something to ask or something to say. Right. So in this triangle, we essentially have at least one angle, and you have one side, right, which is this side. Right. You are given here, even on the diagram, it's 35 millimeters, which I've labeled here as 35 millimeters. So if you have one side, you have one angle, then essentially you can get either the other angle or the other side, or one of the sides, whichever side you might be looking for. In this case, we're looking for EF. Right, so once you have EF, essentially you will have this measurement, and 125 minus twice EF will give you CG. Right, just a couple of things you need to work out in your head, right, before even starting your solution. Right, once that is done, essentially half the problem is solved, because you've already established that in order to get X, you need to know AB, BC, right? You need to know AB, BC, and CG, right? And that these ones, right? If you find A, B, and BC, you will have inadvertently established what these measurements are. Right, so here I started with calculating CG, right? So first I calculated EF here using triangle. I called it EFC. So this triangle here, the blue one, right? I used the angle E, which we've just established that it is equal to 55 degrees, seeing that this angle alternates with this one, which we are given as 65 degrees. Right, and then I calculated EF. Right, so bearing in mind that the angle I'm using is here, the side I'm looking for is adjacent to the angle I'm using. And then I have a side that is opposite the angle, which means I can only make use of tan in terms of which trig ratio is convenient for us to use here. And so because the side I have is opposite the angle and the side I'm looking for is adjacent to the angle, right, so that is why I use tan. So tan E is equal to opposite. Right, so the opposite side is FC, which is the side, divided by the adjacent side, and this EF is the adjacent side. Right, and then we make EF the subject of the formula, meaning that from this, if you make EF the subject of the formula, this is what you get. And then in substituting, FC is equal to 35, right, divided by tan E, right, angle E being 65 degrees. And then, of course, if you punch this in your calculators, you get 16,321 millimeters. Right. That way, we have EF. We've already established that 125 is actually equal to CG plus 2 times EF. Right, so to get CG, you then use that expression. Right, 125 is equal to CG plus 2EF. You then substitute EF here. So 125 minus this gives us 92,358 millimeters. Any questions so far?
No, sir.
Right, pretty straightforward. Right, so at this point you have CG. Once you have CG, the only measurement to calculate now or to establish is BC, because you already know AB is the radius, and this measurement is equal to this one. So the only measurement to establish now is BC. Right, then having to calculate BC, we know to get BC we need this angle, angle C, from triangle BCD. Right, I called it triangle BCD. All right, so in triangle BCD, we've already established that angle C will be half of 65. Right, half of 65 is 32,5 degrees. Right, and then having to calculate side BC with the angle C. The side we have is opposite the angle. The side we're looking for, BC, is adjacent to the angle. Hence, again, there we use tan. So tan C is equal to the opposite side, which is BD, the radius, divided by the adjacent side, which is BC. Right, that is where this comes from. And of course, we are looking for PC, so we make PC the subject. Hence, manipulating this to making BC the subject, we get BD divided by tan C, C being equal to 32.5 degrees. And then if we punch this in your calculators, we get 19.621 millimeters. Right. Once you get BC, essentially the problem is done, because you know the expression to get the distance x, right, will be 2 times AB. AB we've already established is the radius, so 2 times the radius plus 2 times BC plus CG. Right, that is where this expression comes from. Right, at this point, you already have the radius, you have BC, and you have CG. Right, so all you do is substitute. Upon substituting, this is what you should get, 156.6 millimeters. Right, and you get your full marks, 7 marks. Any questions? No questions. Wonderful. Now, you must be careful with precision measurements. If you mess up one measurement, yeah, it's pretty much over. It is pretty much over. Right? It's one module that is quite easy, right? But it can be quite unforgiving. Right? If you use the wrong angle, it's pretty much over. Right? That is why it is important that you understand how you approach problems based on precision measurement. That's why I explained concepts like the meeting of two tangents. Right? If you have a roller and there's two tangents meeting at a common point, how you get to use those two tangents. Like in this case, right? You have this tangent, you have this tangent. They are meeting at this common point. Hence, we are able to draw a line where the two tangents meet, right, to the center of the roller, right? Hence, establishing or developing this triangle, which we'll then use to calculate that side, right, or this distance. Right? Such concepts are very important that you guys understand, right? And then in having to attempt problems based on precision measurement, right, before even starting with your calculation or solution, right, so you draw the diagram or show all the important labels, triangles, right? Break it down in your head, right? Asking yourself what exactly you or which measurements you need to establish in order to be able to calculate the one you are looking for. Right. Also concepts like the parallelogram, very important that you understand that as well. Right. It's going to come in handy for some of these problems. Right. So that is why I take you through the concepts that you can use here in precision measurements. Otherwise, precision measurement is quite simple, quite easy. Like I said, it can be unforgiving because one mistake could essentially cost you the entire solution. Are we clear?
Yeah, mighty, the Almighty God. Just a quick one, man. You said on your instruction, you said that your answers must be in 3 decimals.
Yes.
Looking at the value of x, whereby your x is 156.6. You don't have to put those 2 zeros at the end, right?
Nope.
Okay.
No, you don't have to. If the two numbers after the first number after the comma are zeros, no need to put them. Because They won't help us in any way in the solution. Right. The only reason why we even round off to great decimal places is for accuracy purposes. So the 2 zeros won't help us anyway. Now, Ioda.
Got it. Thanks.
Right. Now let's look at 1.2. 1.2 is as follows. Figure 2 below shows a workpiece with a V groove which has a 60-degree angle included, which has a 60 degrees included angle and a depth of 50 millimeters. Right, so we have a diagram. I've redrawn the diagram here. It's always convenient for you to redraw the diagram. It doesn't have to be nice, it just has to be proportional. It's because your calculations will be based on the labels you put on the diagram. Right? It makes it easier to mark if you give us context instead of you having to write here in triangle BCD and yet we have no idea where that BCD is. Right. Right. So 1.2.1 is said refer to figure 2 above and name the numbered components. Write only the answer next to the corresponding number 1 to 4 in the answer book. Right. Right. So number 1, right, this here is number 1. This is simply a V block. And number 2 is pointing at the precision roller. Right, so this here is a precision roller, not a precision ball. But if you wrote precision ball, I'll give you a mark for it. It's incorrect though. Right, in the exam, you might not be so lucky. But for the first assessment, if you wrote precision ball, right, I'll give you a mark for it. But the right name for the components, this component in particular, is a precision roller, or you can say just a roller. Now, if you wrote just ball, that will be incorrect. But if you said precision ball, I'll give you a mark for it. All right, but do know that that is a mistake. Right, this here is a precision roller. Then number 3, right, these are gauge blocks. In some of your textbooks, it's been referred to as a slip gauge. So if you wrote gauge block or slip gauge, you get a mark. Right, and then this here is the straight edge. Right, there is no other name for a straight edge. It's just straight edge. So if you have something else there, right, if you have anything else except straight edge, it will be incorrect. Right, you get your 4 easy marks. And 1.2.2 is a use figure 2 to calculate the thickness of the gauge blocks H. So they want us to calculate this here, the height of the slip gauges or the heights of the gauge blocks. All right, again, before having to attempt your calculation, you look at what you have. All right, you have this H. All right, you've been given this here at 50. All right, this is 50 millimeters. You've been given the diameter of the roller, which is 40 millimeters. Right, so essentially, in order to get H, right, precision measurement is all about having to develop algebraic expressions. Right, so you have H here and you have 50, which means it's more than likely that in order to get H, right, you need to get this expression. Hence, you have to label your diagram accordingly. Hence here, I called this my A, called it B, and I called that C. Right. Also, you must be careful not to over-label your diagram. Right. Only give labels where it's appropriate. or where it is necessary. Right, so by so labeling our diagram, we essentially mean that we have an expression for AC. Right, so AC is equal to AB plus BC, but AC is also equal to H plus 50. So that straight away gives you an idea that in order to get H, you need to get AC. Right? Right, having established that, you now ask yourself, how are you going to get AC? Right, what is AC also equal to? AC is also equal to AB plus BC. AB here is equal to the radius. We have the radius, seeing that we have the diameter. Diameter is 40, radius must be 20. So we have AB, but we do not have BC. Right, so to get AC, we have AB, but now we need to get BC. How are you going to get BC? By simply drawing this triangle here. Right, we know that this line, right, is equal to the radius. So meaning that we know that BD is equal to the radius, hence it's equal to 20. Right, do you have any one of these angles between this one and this one? Yes, you've been given the included angle here, which is 60 degrees. Right, again, remember the concept, two tangents meeting at a common point. Right, so meaning that this line equally splits these two angles. So if this entire angle is 60 degrees, it means this is 30 and that's 30. So in triangle BDC, we have the angle C, which is 30 degrees. We have one angle, we have one side, so which means we can get the side BC, which according to triangle BDC is the hypotenuse. Right, that is why here I then said in triangle BCD, right, the angle C is 30 degrees, right, and then to get this side, right, the angle that we have is 30 degrees, angle C. The side we have is opposite the angle. The side we're looking for is the hypotenuse, which means from the three trig ratios, we can only use sine. Hence here I said sine 30 is equal to opposite. So the opposite side is the radius, BD, divided by the hypotenuse, which is side BC, the one we are looking for. Right. Sine 30 is equal to a half. That's why here I have a half is equal to BD over BC. And then to get BC, you simply cross multiply here. Therefore, meaning BC is equal to 2 times BD. BD is the radius is 20. So 2 times 20 is equal to 40. Right, so BC is equal to 40. So BC is equal to 40 millimeters, which means now we can get AC. Remember, we had already established that AC is equal to AB plus BC. Right, which means AC is equal to 20 plus 40, which means it's equal to 60. Right, so having attained AC, it means now we can get H, right, by simply manipulating this, making H the subject of the formula. Hence, when you transpose this, you then get 60 minus 50, which is 10 millimeters, which means H is therefore equal to 10 millimeters. Any questions?
Just a quick one. If you see that there by angle C, you said that it's 60 divided by 2, which gives you your 30.
Yes.
If you didn't write that, but you only indicated it by your drawing, will you be wrong to say
Nope.
that those two angles they split, which is 30-30 on the other side, 30-30?
Nope, you wouldn't be wrong. Even if you look at the mark allocation here, there is no mark allocation for this. But you do include it there for context. So if you say included it in the diagram, that's perfect as well.
Sure.
Yes. Any more questions? Right. So that is it as far as precision measurement. Right. Now, precision measurement will be in the second assessment. So if you are still struggling with this, make sure you um, give it more practice. And then if you have questions, you can ask the group for help. Failing which, you can ask me for help as well. Are we clear? Hello.
Yes, sir. We are clear.
Yes, sir.
All right. Right. We are done with question one. Let's move on to question two. Right. Question two, I felt was quite simple as well. It's based on hydraulic systems. I didn't go too crazy. I only included questions based on the first part of hydraulic systems. So, as far as hydraulic systems, if you did read the guidelines or the breakdown of the units included in hydraulic systems, you know exactly what I'm talking about when I say I only included the first part. So the first part is being familiar with Bernoulli's equation, knowing how to apply Bernoulli's equation when not or when we've disregarded um, what is this energy losses or frictional losses, and then also knowing how to apply Bernoulli's having regarded or having taken into account frictional losses. And that's at this level, we look at two ways in which we can account for frictional losses, which is by using Darcy-O'Share's formula. Right, so that is pretty much the first part. And then the second part is where we look at measurement of flow. So measurement of flow incorporates flow through an orifice as well as flow through a venturimeter. So in the second assessment, you can expect flow through a venturimeter and what is this? Flow through an orifice. Are we clear?
Yes, sir.
Right, so 2.1 reads as follows. A horizontal pipeline with a diameter of 90 millimeters conveys water at 30 liters per second with a pressure drop of 60 kilopascals per 20 meters per 20 meters of pipeline. Right. Now first interpret the information you've been given. So they say here you have a pipe. It has a diameter of 90 millimeters. So the pipe is a constant diameter. It's not a tapered pipe, right? Which means even your velocity will be an average velocity across the length of the pipe, seeing that it is not tapered. These are just some of the things you can establish as you go, right? Before you even get to questions, right? Pipe diameter is constant, right? Which means which suggests that the velocity will be an average velocity or will be more or less the same throughout the fluid's motion. And then we are given Q, which is the flow rate of the water. The flow rate is 30 liters per second. Right now, 30 liters per second isn't the standard unit of measurement for flow rates. The standard unit for measurement or the standard unit of measurement for flow rate is cubic meters per second, which then means you obviously have to convert the 30 liters per second to 30 or to cubic meters per second. So you have to convert the liters per second to cubic meters per second. Right? And the way you convert from liters to cubic meters is by dividing by 1,000. Right, so the per second is correct. We just need to convert the liters into cubic meters. And again, the way you do that is by dividing that by 1,000. Right, you have a pressure drop of 60 kilopascals per 20 meters of pipeline. Now, what does it tell us? This tells us that the change in pressure is 60 kilopascals for every 20 meters of length pipe, right? Which tells us essentially that we don't necessarily need the entire length of the pipe, right? The fact that we've been given the pressure drop for a length of 20 meters of the pipe essentially tells us that you have the length, right? So the 20 meters is the length we are going to use, right? Because we have the pressure drop or the change in pressure, right, for only the 20 meters. So we'll be able to calculate whatever it is we need to calculate here, right, based on the pressure drop, which is 60 kilopascals, which occurs every 20 meters of the pipe length. Right, so however you look at this, right, not knowing the entire length of the pipe, right, is meaningless to us because we can just focus on only 20 meters of pipe length because we have enough information, right, for the 20 meters of pipe length, right, which essentially means that 20 meters is the length of the pipe, essentially, right? So having established what exactly you've been given, you now look at your questions 2.1.1, calculate the value of the coefficient of friction F using Darcy's formula, right? Now, Darcy's formula has two variations, right? One variation is based on the flow rate, so you use Q, and then the other variation is based on velocity, right? The velocity of the fluid flowing through the pipe. So you use whichever one is convenient. So the one that's convenient, I would say, is the one where you've already been given the quantity. Right? So by giving the quantity, I mean you would have to be given either Q or the velocity of the water. Right, so remember to mute yourselves. Huh? Yes, thank you. Right, so I was saying, whichever variation is convenient, by that I mean, so we are aware that there are two variations of Darcy's formula. One where you can use Q and one where you can use the velocity. So the one that's convenient would be the one where you've been given one of those quantities, so between Q and velocity. So in this case, for instance, you've been given Q, so it makes it convenient for us to use Darcy's formula that is in terms of Q. It's convenient because you don't necessarily have to first calculate the velocity before having to calculate or before having to use Darcy's formula that is in terms of velocity. Right. So in having to calculate the coefficient of friction, we know the equation where we can calculate the coefficient of friction is Darcy's formula. All right. Or let me say Darcy's formula to calculate. Okay, the other one is actually Chase's formula. So this is the only one because the other one is Chase's formula. All right. So the only formula to calculate, or the only formula to use to calculate the coefficient of friction, that is Darcy's formula, is this one here. All right. So from this formula, you look at what you have, the quantities that you have. Right. You don't have HF. You're looking for F. You essentially have the length of the pipe because we're only focusing on the 20 meter of pipeline. And then we have Q and we have the diameter of the pipe. So that is why that before having to use this formula, seeing that at the moment you have two unknowns, you first have to calculate HF The way you calculate HF, this you should already know. By applying Bernoulli's equation, right, it comes down to HF being equal to change in pressure divided by rho G. Are we familiar with this formula? Or are we familiar with how we get here? Yes, no? I did explain it in one of my videos. Hello? Talking.
Hi, sir.
Yes, you
Yes, you
did.
did explain. You did explain on your videos that we must be able to do anything that we are given as a subject of the formula, even though we are not required to show all the steps.
Yes, yes, that is exactly what I said. Yes, that's correct. Right. So as long as you understand where this comes from, right, you don't necessarily have to apply Bernoulli's every time you come across such an exercise. Right. The fact that you understand that based on the given information, it means if you apply Bernoulli's, right, you are right. You, essentially, it's going to come down to this formula here. You can simply use this formula, or you can simply use this as a formula. Right. So changing pressure, we've been given it's 60 kilopascals. Right. The standard units of measurement for pressure is pascals. That is why we have to convert the kilopascals to pascals. And in doing so, you simply multiply that by 1,000. That is why here I have 60 times 1,000. Let's divide it by the rho or the density of water. If it's not given, you assume it's 1,000 kilograms per cubic meters. And then G for Meccano. Right, so G for Meccano on all levels is 9.81. And then we get 6.116 meters. That becomes our HF, which then means that now in Darcy's formula, right, we only have one unknown, which is F. Right? And then you make F the coefficient of friction, the subject of the formula, which then the formula becomes this. Then all you have to do now is simply substitute HF, just calculated, it's 6.116, right, times the 3.026 times the diameter, convert the millimeters to meters. Right, in doing so, you have to divide by 1,000. So from millimeters to meters, you divide by 1,000. And then to convert from meters to millimeters, you multiply by 1,000. Right, that is where the 0.09 comes from. I divided the 90 by 1,000. Right, so you get 0.09 to the exponent 5 divided by the length, which, as we've established, we are only focusing on 20 meters of the pipeline. So the length is 20. And then Q, 30 divided by 1,000 is the 0.03. And then, of course, you square that. And punching that in your calculators, this is what you should get. Now, the coefficient of friction is dimensionless. That's why here there are no dimensions. All right, so you get 6.071 right, times 10 to a negative 3. Right, and you get your 5 easy marks. Right, then 2.1.2 on the question paper reads as follows. Use Shez's formula to calculate the hydraulic mean depth, even indicated here that I am referring to M. Right, so hydraulic mean depth is simply the diameter of the pipe, the diameter of the pipe divided by 4. So 0.09 divided by 4, which is this 0.023 meters. You get your 2 marks. Right, straightforward. And then 2.1.3 says use Shez's formula to calculate the hydraulic gradient, I. Right, so you now have to calculate I. Right, so remember at this point, in having to understand how to use Darcy and Chase's formula, one thing is clear, that in having to calculate the frictional head loss, HF, whether you use Darcy's formula or you use Chase's formula, you should get more or less the same thing. So bearing that in mind, having calculated HF here, and this is what you got, in having to use Chase's formula to calculate the hydraulic gradient, I, it means we already have HF, and of course we have the length of the pipe, which is that 20 meters of pipeline. So you simply manipulate this, making the hydraulic gradient the, what is this? What's what I'm looking for? Well, it's making this the subject of the formula, which then that will equal to HF over L. HF we have, L we have, and then we get 0.306, which again is dimensionless, as the hydraulic gradient is also dimensionless. Right, any questions so far?
No, sir.
Right, 2.1.4 calculates the Chase's
I have a
constant.
question.
Yes.
I have a question. So what I didn't use just this formula. I used the other one, I think, because instead of Q, which is your flow rate, I looked for the velocity, which the values are correct, but the substitution was the problem. Because where there's Q, I put in V squared and all of that, and my answer is totally different. Does that mean that is incorrect?
Okay, my question to you is, so you used this formula, for instance, this is the formula you used.
So
Is
let
that what you
me
said?
read from my question. So I used I started by looking for velocity as the first step. Then I looked for the area also, and then I went on and looked for area of the pipe.
Okay.
And then I looked for the head loss, and then the value for head loss was 6.116. The velocity was 4.712 ms, and then the area was 0.006366. Then I substituted in that formula. So my
In which formula?
2.11 is, my formula
In which
is a. Yes, I'm reading it. My formula for 2.11 is F is equal to into HF plus 2G times
HF
D
times
O,
2G.
sorry,
You said HF times
HF
2G.
times 2G times D over the length times V squared.
Times V squared.
Yes. And our answers are different.
So the answer you got for F is different. Or the answer
Yes. The substitutions are fine. The values that I substituted are fine, but the only problem is your answer and my answer because of the formulas that we used.
Okay, so my question to you is this a formula for calculating the coefficient of friction or for calculating I?
Yes. It's for F.
So F.
Yes. My I at the bottom is fine. My my 2.12 is fine. My 2.13 is fine. Everything is fine except for this H1, which I used that formula instead of yours.
Okay.
But then at the top, I started by looking for velocity already, and then the area of the pipe and the head loss. Then I use those values, which are similar as are the same as yours, because I got for head loss I got 6.116, and velocity 4.712, and then yeah.
Okay, I'm trying to figure out this formula of yours. So essentially, because if there's V squared, it means.
If I'm not mistaken, say the formula that that she's saying it's the same formula on the memo that she sent. I think you sent us the memo yesterday around this time. I think if I checked, it wasn't the same as this one, the answer, if I'm not mistaken. I'll quickly check now.
V
Is it the memo?
squared divided by C squared times I. Okay, once you have this, so C squared is going to be C squared is going to be I. So V squared over C squared is 2G over F, then times M.
Yes, sir, I got the memo and the answer is 0.0244 for the memo that you sent, with an equation HF is equal to F times length times V squared over 2 times G times D.
Where is this thing coming from? Okay, let me just try to work this out. This formula that she used, because I think it's supposed to go like this: V squared over 2G. Okay, so that's I. And then, but how do you come to this? Because if you use this, it means you used HF is equal to I times L, and then HF is equal to V squared times F over 2G times M, and then times L here. Okay, and then to get F, you have to say F is equal to HF times 2 times M divided by V squared times L. So the bottom part is correct, top part is incorrect. So here you are missing times M here. I see what you did. So this is what you did. You're missing M. But even if that is what you did, you are still incorrect. Why? Because to calculate F, the coefficient of friction, you are told to use Darcy's formula. So once you incorporate I, you are now using Chase's formula, which means even if you took this approach, right, and wrote the formula correctly, and even got the answer correctly, you will get 0. Why? Because you didn't use Darcy's formula. Where are you?
I'm still here. Okay, no problem.
Yeah, so I can see what you did. This is exactly what you did, but again, you missed one here, right? You missed the M. The M was supposed to be there as well. So you're supposed to have this times M, this one here. But even then,
Because
you'd be incorrect because the instruction is clear, using Darcy's formula. I don't know if I'm making sense here.
okay, I will check and I will check on the textbook because I confirmed from the textbook, but I will check and then revert. Thank you.
All right, but if this is what you did, yeah, you will be incorrect because this formula incorporates Chase's formula. You saw how I just what is this? You saw how I just derived the formula, right? I had to use
Yeah.
Chase's formula.
Okay,
Right.
no, I will check.
Right, but using it isn't as much as it gives you the same answer or should give you the same answer. Right, the fact that here the instruction says
No, it
calculate the
doesn't. It
coefficient of
doesn't
F
give the
using
same.
plus this formula. So you didn't get the same thing because you didn't multiply by m.
Yeah, because I used
Yeah.
D
Yes.
on top.
Yes.
Yes.
That's why you didn't get the same thing.
Okay, no problem. Because the bottom ones are fine. Okay.
Any more questions before we move on?
Hi, sir.
Sorry, sir.
Yes.
Oh,
Okay, let's take the
Good evening, sir.
yes.
I just need to ask, sir, in 2.1.1 for F, I rounded off and I got 0.006. So
Yeah.
I substituted that answer into 2.1.4. In that formula, C equals square root of 2G over F. So my answer I got is 57.184, not the same as yours. I just want to know, will I be incorrect or because I noticed the answer you did for F, you had something else.
Yeah, it's the same thing. Okay. Maybe it's off by certain. What is this? So this is what you. This is the formula you used to calculate C. And
Yes,
then here
yes,
you use 0.006,
yes.
and you got 57,
57.184.
which is the same thing. Here I got 56,849, which essentially is 57. That's fine.
Okay. So is it fine like that?
It's the same thing.
Okay. I just wanted
Remember,
to clarify.
okay. No, in fact, I think it's good that you brought that up. So we don't mark, or let me say, I do not mark answers. I mark the approach. The approach is what is important, right? So the approach is what is important. So your approach here is perfect, hence everything is correct, right? The values might differ here and there, right, because of how we expressed some of our answers here, right? Like you said, instead of writing the answer using engineering notation, you simply instead used 0.006, which is not incorrect. Right? Because this can be expressed as 0.006, which is still rounding off to 3 decimal places. Right?
Okay,
So
thank you.
it's not incorrect. But the most important part here is that I do not mark answers, I mark the approach. So as long as the approach is correct, then you should be fine. Right? The only time you'll be wrong is if you substitute something that is completely wrong. Right? But if it's a matter of how you expressed your answer, then you should be fine. Because I'll be looking at the approach anyway. Happiness. Hello. Happiness. As in, are you happy?
Yes, sir.
All right.
Yes, yes.
All right. Let's give the lady a chance.
oh, sir, I just wanted to know in what group did sir send that memo in?
Which memo is this now? I don't know which memo they're
That
talking
the
about.
other two ladies were talking about.
I have no idea what they're talking about.
Okay, cool. Thank
No,
you.
that was not a memo. I think the student he sent in the wrong group. I think.
Oh, okay. Okay.
Yeah.
Okay.
All right. Well, there we go. Yeah. I did because I know for a fact I didn't send anything yesterday regarding hydraulics. Everything regarding hydraulics I sent everything long time ago. Right. But I think that is cleared now. So I think you have been answered as well.
Yes, sir. Thank you.
All right. Right. So this is how you calculate HF, and then to calculate 2.9.4, calculate Scherzi's constant C. All right, so there are two approaches you can use here. All right. The first one being having to calculate V from this formula. We've been given Q. We have the diameter of the pipe, so you can get the area. Hence, you can make V the subject of the formula. In doing so, this is the approach I took. And then this is what I got. It's 4,716 meters per second. And then took that velocity, right, and substituted it in this formula. Right. At good point, you will have V, you've calculated M, and you have the hydraulic gradient. So you can calculate C by making C the subject of this formula. Making C the subject, this is what we get. And then we substitute, and we get 56,215. All right, and then C is dimensionless as well. So you could either take this approach, or you could take this approach, which is much quicker. Where we say C is equal to the square root of 2G over F. Right, G is 9,81 for Meccano. And then F, you substitute the F that you got in 2.1.1. Right, it is good practice that you make use of engineering notation, right, for such small answers. 0,006 is very small. Right, so it doesn't do us justice if you use it as 0,006 in terms of accuracy. Right, that is why you must make use of engineering notation there. So get used to using engineering notation, because you definitely will be using it in N5 and N6. So for strength of materials, Meccano N5, power machines N5, as well as the next level. Right, so get used to using or knowing how to use engineering notation.
Sorry,
Right.
say.
Yes.
I wanted to ask if on 2.1.1, when I was calculating my coefficient, I've used the formula that has got the velocity. The formula that has the velocity. Okay.
So that is 2F times L times V squared over G times D. It's this one.
Yes.
Yeah.
I've calculated my area first and then calculate my velocity. On 2.1.4, I didn't calculate my velocity. I
Okay, so
just substitute.
so you calculated your velocity here. And what did you get?
Yes.
Is it anywhere close to this one? What did you get? You said you got 4,712, something like that.
Yes.
All right, so you got 7,712 because you calculated the area instead of substituting like this. So you calculated the area on its own.
I've calculated the area on its own and then substitute on the formula Q is equal to.
And then you said F is equal to HF times G times D divided by what? Divided by 2 times L times V squared. Is this what you did?
Yes.
And then what did you get? So on this one, what did you get?
Oh, I don't have papers now, but I remember that I did in that. My question was
since I didn't calculate it on 2.1.4, the velocity, I just substitute it from the
Yeah.
one that I've calculated.
Yeah.
Am I going to get the full marks?
Yes.
Oh, okay, thanks.
Because you had already calculated it. No need to calculate it twice.
Okay, thank you.
Yeah. So don't worry about that. Okay. Any more questions? No questions. All right. So 2.1 is done. Now we can look at number 2.2. All right. So there was a typo here. I wrote 3, but essentially this is 2.2. All right. So it reads as follows: a horizontal pipeline of diameter 90 millimeters increases uniformly to a diameter of 180 millimeters in the direction of flow. When water flows through the pipe at 100 liters per second, a pressure gauge at the 90 millimeter section reads 225 kilopascals. Ignoring all losses, calculate the pressure at the 180 diameter section. Right, so we have a tapered pipe here. Right, you have a tapered pipe. The diameter at inlet is 90 millimeters, and the diameter at outlet is 180 millimeters. And we know that the diameter at inlet is 90 and at outlet is 180 because they said you have a pipe which is 90 and increases uniformly to 180 in the direction of flow. So we know that the way the information is given is based on the direction of flow. So the fact that they mentioned the 90 millimeters first into the diameter increasing to 180 millimeters in the direction of flow, that means that 90 is our inlet and 180 is our outlet. Very important that you are able to establish which of the two sides of the pipe is the inlet and the outlet. Right, and then here they've indicated that by telling us that the information is basically in the direction of flow. So now you know that the 90 millimeters is 0.1 and the 180 millimeters is 0.2. Remember, 0.1 represents inlet, 2 represents outlet. And they say when water flows through the pipe at 100 liters per second. So essentially, you've been given the flow rate of the water flowing through the pipe. Right? They've given it to us in liters per second. Obviously, you have to convert that from liters per second to cubic meters per second by dividing by 1,000. Right? Hence here, in dividing 100 by 1,000, we get 0.1 cubic meters per second. Right? And they say pressure gauge at the 90. So essentially P1 is 225 kilopascals. And they say to ignore all losses, calculate the pressure at the 180 millimeter diameter section. So they want us to calculate P2. Right, so here clearly we are going to have to use Bernoulli's expressions, right, or one of Bernoulli's expressions. So seeing that they want us to calculate the pressure, P2, that is why I've used the variation of Bernoulli where each of the terms is in terms of pascals. Right. So before doing so, we know in having to use Bernoulli's, we have to establish the velocities. Right. They said here the pipe is horizontal, so we know that the H's or the what is this? the potential what is this thing? The potential energy, right, is going to be 0, seeing that the pipe is horizontal, right? So the Z measurement is going to be the same for the inlets and the outlets. Hence, the potential energy is going to be 0. All right. But seeing that the pipe tapers, it means there's going to be a change in velocity, hence a change in kinetic energy, which is why it is important to establish what V1 and V2 is equal to, which here is quite easy because they've given us Q. Right, seeing that they've given us Q, you can simply use this formula in calculating V1 and V2. Right, so in calculating V1, right, it just means you have to use the diameter at inlet, so D1, which is that 0.09 meters. Right, so in doing so, we get V1 as 15.719 meters per second. Now, before even doing these calculations, you can work this out in your head, thinking that, or looking at how the pipe tapers. So the pipe tapers from a small diameter to a bigger one. So now you consider how that affects the velocity. Is the velocity going to increase from V1 to V2, or is it going to decrease from V1 to V2? Right. So the speed of the water, or the velocity of the water, tends to go slower at a much greater diameter or area, right? And it tends to go faster at a much lesser pipe diameter or area, right? Which means essentially what is happening to the water here, the water is slowing down. So it's not accelerating, it is decelerating, which tells you that in calculating V1 and V2, V1 must be greater than V2, right? So in having to calculate V1 and V2, you've already established, or you already have it in mind, that V1 must be greater than V2, right? So after having calculated V1, you then calculate V2, which you expect to be less than V1. And then in doing so, you do find that V2 is less than V1, which in all likelihood tells you that you are on the right track. Right. Once you calculated V1 and V2, now you can calculate the pressure you're looking for. In having to use one of Bernoulli's variations, or one of Bernoulli's expressions, right? This is the one I used, right? Because seeing that we're looking for the pressure, it is convenient to use the expression where each term is in terms of pascals, right? Or is in terms of, yeah, pascals, if I can put it like that. So we look at the inlet first. Right, so P1 plus kinetic energy plus potential energy is equal to the outlets, essentially P2 plus EK2 plus EP2. Right? And as we've established, that seeing that this pipe is horizontal, the potential energies, they cancel each other out. Right? Then I simply made P2 the subject of the formula. So you take this term to that side, and then you get P1 plus half rho. And then all I did here was that, seeing that half rho is common for both terms, right, I took it out as a common factor. And then in my brackets, I have the positive V1 squared minus the V2 squared. And then you substitute, right? P1 is 225 kilopascals that you convert to pascals. That is why I've multiplied by 1,000 here, times half rho. Rho you take as 1,000 if it's not been given, right? Then into V1 squared minus V2 squared. Then punching that in our calculators, this is what you should get. It's 240,821 kilopascals. Any questions?
Just a quick question. If I started with calculating the area, given that we've got a diameter, then where I used pi d squared divided by 4, just to calculate my area, so that I can substitute with that area on the velocity, where we'll state that flow rate over the area, which will give me my V.
Yes.
Am I wrong if I did it like that?
You're 100% correct.
Okay.
You're 100% correct. So the way I'm teaching you guys how to do this is based on accuracy. So this is just for this is based on the best engineering practices, right? It is best for accuracy purposes that you take this approach. Now, the approach that you're asking about is correct mathematically, right? But for accuracy purposes, it might cost us, right? It's not great engineering practice to take that approach, even though it is not incorrect, right? It is not incorrect, but it's also not efficient, right? If I was you, I would try and get used to this approach, right? Because in engineering, accuracy is very important. That's why in rounding off, we don't round off to 1 decimal place or 2 for that matter, right? It's always 3 and above, and that is for accuracy purposes. Are we clear?
Okay.
Noted.
I have a question for the future.
Mm.
So you said your Z will cancel each other because what? Okay, let's leave the reasoning. But if you use, because I saw on the textbook there's a formula, P1 over density times gravitational don't plus V1 over 2G plus
Mhm.
Z equal to the same thing, but 2, you put 2's.
Mhm.
So then, because of this is liquid water, so we assume the density is going to be 1000, right? So that is a given value.
Yeah.
And then your 2G. So if you use that formula, will you be incorrect also?
No, you'll be correct. Remember, I said Bernoulli's equations, it has 3 variations. So whichever one of those 3 that you use will be fine. It doesn't matter which one you use.
Okay,
So
because
the one you mentioned is one
mhm,
where each of these terms is in terms of meters.
mhm,
Right. Remember, the first one you mentioned is P over rho G. What is this equal to? H from
yeah,
rho G H, which is pressure.
yeah,
Yes.
yeah.
So the variation you are talking about is still Bernoulli's equation. It's just that each term is in terms of meters. That one is convenient for when you have to calculate one of the H's. But you can use it in having to calculate any quantity. Doesn't matter.
Okay, because remember the first step you would do, like the guy was mentioning, you will calculate your area. Once you get that, you get your velocity. After that, then you use the same formula that I just mentioned now
Yeah.
to substitute the values.
Yes.
That's still fine. But I'm seeing the answers are different when you get
How
to the
different?
bottom, which is the answer.
What did you get?
Very, very different. Because my everything stepically is fine except for the answer. My P2 was my P2 was something else.
What did you get though?
230 point, and I tried 20 times. I checked multiple times.
Yeah, it's too off. It's too off. Cause see, let's see here. Let's see if you calculate the area.
Because I have your 15,000 for your velocity. I have your 3.9 for velocity number 2. And then I have your 2, which is a pressure given value. And what is that half 10? What is it coming from? Your Q. So I didn't use that one obviously. So I use P1, which is given, and then your density 9.8, which is also given, and then V1, which I calculated to 15.72, then divided by 2G, which is given, equal to P2, because Z, I took it out because it's going to be 0 both sides. And then P2 over density times G, which is still given, plus V2, which is your 3.93, divided by 2G, which is still given. And then I substituted my P2 and then look for the value. And then I
Alright.
checked and I checked and I checked.
I will do the same thing just now. So this is what I'm assuming this is what you got for your areas. So this is area 1, this is area 2. Is this how you
Yeah, I
your area?
didn't write them down. I just used them inside the formula.
But
Yeah, the
but
other one
I'm saying
0.25.
this is how
Yeah,
you
yeah,
express
yeah,
it. Yeah.
yeah.
Yes. I want to calculate V1 and V2 now quickly. So this is 0.006. So I get V1 as 16,667 meters per second. And then V2 will be
I don't think it's correct.
25.
Let me just go my side.
This one
0.18.
4 meters per second. All right. So 16,667. That is what I'm getting as the V1, and then V2 is 4. If I use your areas expressed.
No, my the first one is 0. Let me see what is this. The diameter 0.09 gives you a 0.3617 something times to the power -3.
Let's see. All right. So that one is incorrect. So right
The one
on
you
your
wrote here.
on your calculator, write pi. So put in the fraction first, and then the numerator have pi times 0.09 squared.
Divided by 4.
Divided by 4. What do you get?
Yes, I'm getting
6,
6.6.
no,
6.36. Yeah. To the
you
power
see it's
10
different.
times.
But you see it's different. It means you did something wrong.
No, on my answer sheet is correct. I wrote that way.
So you wrote it as 6,362 times 10 to a -3.
Yes.
All right, let's do that.
And then my velocity with yours is fine. My velocity was 15.72 ms. That is V1. My V2 was 3.9298 ms.
So which is
Then the
same.
problem is that when we are, yes, which is still the same. The issue is that when you go to the bottom, which is the answering, because the formula I substituted as per the values that I mentioned. But now if I'm supposed to take P2 to the right, to the left, and then minus whatever the numbers are, I'm getting two different things compared to what you got.
You must have made a mistake, because your values relative to mine are the same. So meaning V1 and V2, they are more or less the same. So which means P2 should be the same as well, more or less. It definitely shouldn't be that far off. So it means you did something wrong.
But if you have time, we can do it now using my formula, and then we see what values you're gonna get.
Okay, let's do it. I don't mind.
Mm-hmm.
All right. So which variation of penalties did you use?
The one with the P1 over density times G plus V1
so you said
2G.
P1 over rho G.
Yeah, plus V1 over 2G.
Plus V1 squared over 2G plus H1 is equal to P2 over rho G plus V squared over 2G plus page 2. And then obviously that goes. So here we are looking for P2,
Yes.
right? And then what did you say? So let's take this to that side. So here we're left with P2 over rho G is equal to P1 over rho G plus V1 squared over 2G minus V2 squared over 2G. And then this
No.
2 over rho G. Are we still together?
No, you swap them around.
Well, mathematically, if I take this to that, then this becomes negative. That's what I did. I only took this to that side, hence it becomes negative. You see what I'm saying?
Oh, okay. I see now the P2. Okay.
You see what I'm saying? Huh?
Minus 2. Yeah, yeah.
So then here, if you substitute, you get 225 times 10 to the 3 over rho G. So that's 1,000 times 9,81 plus V1. What did you get for your V1?
It's 15.72.
15.72 squared divided by 2 times 9,81. Then minus, what did you get for V2?
3.9298.
9298. So 3 squared
Yeah.
divided by
Yes.
2 times 9,81. Right, let's first take care of the right hand side. So on the left hand side, you still have P2 over rho G is equal to, then on the right hand side, you have 225 times 1,000 over 1,000 times 9,81 plus 15,72 squared over 2 times 9,81 minus 3,93 squared divided by 2 times 9,81. On the right hand side, you have 3,4,744. This is what you have on the right hand side. And then, of course, because we are looking for P2, it means we need to get rid of this by multiplying by both sides. You are still together there.
Yes.
So P2
Okay, I see. I think when I was punching the answer, I didn't put that clear.
times, so rho is 1,000, G 9,81. So you simply multiply the answer by 1,000 times 9,81. Should get the same thing, which you do. So this is 340,837 kilopascals, which is not that far off.
Yeah, I
You see?
think I missed the square for one side. Yeah.
Yeah,
When I was punching the
yeah, you definitely miss something. Hence, I say whichever variation of Bernoulli's equation or expression that you use, as long as you manipulate it correctly, you will get the same thing.
Yeah. Okay, nice.
All right.
Thank you.
All right, cool. All right, any more questions here? Or comments, anything? All right. So this is how best to approach these problems. Right. These modules will be included in the second assessment. Right. And then, of course, gear drives, which have shared the content thereof, as well as bearings and belt drives. Right. Before we end today's session, I just wanted to find out if you guys have any questions regarding what is this? Regarding gear drives. Right. I'll share this in the group after the session. Sorry about the noise. Seems my neighbor is busy with some work. But are there any questions regarding gear drives? Have you guys even looked at gear drives? Remember, gear drives essentially has two sections. It has simple and compound gear trains, and then it has epicyclic gear trains, of which I shared all the content thereof. So have you looked at gear drives, or have you started looking at gear drives? And if you have, is it because you guys understand the content up to so far? Is that why you're not asking questions? Do you still need a bit of time before you ask questions? What's the story?
Yes, sir.
Yes, sir.
Yes, sir. I still need a bit of time.
All right. So make sure you go through gear drives. By this time next week, you should have a pretty good idea as to what exactly you understand and what you don't understand. So that if I have to say cut maybe one module, maybe instead of adding belt drives, we could leave belt drives and only have precision hydraulics, gear drives, and also other one bearings. Right, but it is important that you guys do the required work. Right, because remember, the second assessment won't be an assignment. Are we clear?
Yes, sir. We clear.
Yes, sir.
All right. Good luck to all of you. I haven't started marking yet. To those that are on the
The question.
okay, I'll come to you just now. Remember, we discussed the issue of you having to send your scripts, that it was compulsory for those that are in Cape Town to submit their scripts face to face. I got word today that you guys have to go to the campus tomorrow to submit what is this? To submit your scripts, those who are in Cape Town. Because there is an issue with the printing machine apparently. So they don't want to find themselves having to print a lot of scripts unnecessarily. Right, so those that did write and are in Cape Town should hand in their scripts tomorrow as early as possible.
What time are you closing the campus?
It doesn't matter. The scripts you can leave with the security guards.
Okay.
Yeah, you can leave the script with the security guards.
So
Because I
then,
knock
sir,
off at
does that
5.
mean? Oh, sorry.
Second,
Mighty,
Because I knock off at 5.
at Kuru campus, they knock off at, I believe, 4 p.m. Yes, I think it's 4 p.m. But the security guards will always be there.
Okay, no problem.
sorry, Mighty. Even though you submitted via email, you can still submit physically.
Yes.
That's what you're saying.
Yes, that is exactly what I'm saying. That if you are in Cape Town, right, but you submitted via email, you should go and submit your script physically. Right, I haven't received your scripts anyway because they haven't been printed. No,
Okay,
no marks.
noted.
No marks will be docked. Don't worry about all of that. Just make sure that you submit your scripts on campus tomorrow. Right, and also please, if you can, try to be there as early as possible. Right? If you can't, you can't. But I'm just saying it would be best if you can go there as soon as possible tomorrow. Right, I'll also
Okay,
share
sir.
this.
So so I wrote 3 tests this week. Must I submit all of them, or can I do that tomorrow? All 3 of them.
Have you written all 3?
I've written all 3, yes.
Yes, submit all of them tomorrow physically. So you
Okay, thank you,
emailed
sir.
all 3.
No, I didn't email today's one yet. I wanted to join the class first.
Okay. Right. So do not email it. Just hand it over tomorrow. As in the
Okay,
one
thank you,
that you
sir.
received today, you can hand over tomorrow.
Okay.
Right.
And last one,
Sorry.
sir. I just wanted to confirm the test 2 dates. Is it still is it the 4th, right? For our test for Mekano, 4th
Okay,
of March.
let's go there now and confirm that all of us are here. You guys can still see my shared screen, right? Hello, can you still see my shared screen?
Yes, sir, we can still see it.
Right, so there's Meccano. Meccano is still the 4th, yes. And I can tell you right now, that one is not going to change. It's going to be the 4th. So everything for the second assessment will be as per normal. Right, you write on campus. Those who aren't in Cape Town will write online at 6 p.m. Right, so everything is essentially back to normal for the second assessment. Confirm you guys received the timetable.
Yes, we received the timetable, and for finals, we received the timetable.
Yeah, all right. Wonderful.
Now, sir, who do we email regarding test 2 if you're not going to be in Cape Town?
Email me, CC Mr. Kulubela. Remember, I already communicated it. So you email me, you CC Mr. Kulubela with whatever proof you have that you won't be within the, what's the range? I think it's 100 kilometers, something like that. If you're not going to be within that radius during the time of the second assessment, right, you should email me, CC Mr. Kulubela, and then, of course, attach your proof.
Okay, thank you, sir.
Right.
I got a question, sorry, regarding the submission of the test. What if you can't make it tomorrow? Because I mean, we all have jobs and things to ride all the way now. I'm in Simonstown based. You understand? Because I emailed both my scripts, so now you're telling me I must hand deliver tomorrow. My boss is not gonna give me anything like that to get off.
Yeah.
Time
so
off or whatever.
That's totally understandable. So if you can't make it tomorrow, that reason is pretty straightforward. So you should be fine. So the problem here, the problem here is that they want to minimize the number of scripts that they have to, print. Right, because now they have to go to a different campus to print those scripts. Right, so we do understand that because this wasn't communicated clearly. Right, so if it's too much of a bother for some of you, that's understandable.
Will there be a grace period, like maybe Friday afternoon or something?
I don't think so, because Friday afternoon, by then the scripts should be with the tutors for marking.
Okay.
By now we should have already marked. So to submit on Friday, we'll be cutting it really close. So no, don't worry about it. Your reason is quite valid, my guy. So don't worry about it.
Okay. Okay. Thank you very much.
All right. Any more questions?
So just to clarify things, test 2 will have what was on the assignment, the topics, plus the other 2 or 3 topics that we have.
Yes. So here's the assessment plan. Right. So for test 1, it was hydraulics and precision measurement. Test 2, these ones. Precision
We can't
hydraulics.
see. We can't see your screen. It's wide open. You can zoom it. I don't know if I'm the one.
Right.
It's on the left side. I only see 1400.
You only see
I don't know.
1400.
Yeah, I don't see anything else beside that
What about
because
others?
I'm using the phone.
Okay, wait. Because I have no idea what's going on. Let's see.
Can minimize.
Don't allow. Cancel. Okay. Okay, I'm gonna reshare my screen. How about now?
Nothing.
Still nothing.
Yeah, on my side, nothing.
You're not sharing it all now.
Okay.
Nothing on my side either, sir.
Yeah, now it's showing.
Okay, I guess the feed is quite slow because on my side it says
We can
Should-
see it now, sir.
all right. All right, can you see this now?
Yes, can see.
Right. So here are the modules for test 2. So precision and hydraulics as per test 1, and then gear drives, bearings, and belt drives. But I will consider taking away belt drives. We'll discuss this on Tuesday next week during our session. So Tuesday, our session is on Tuesday, 6 p.m. So next week, Tuesday, when we have a session, we'll discuss the best way forward for all of us.
Okay.
This has been a really weird trimester. So I'm going to be lenient, hence taking your views as well.
Thank you.
All right, any more questions, comments, anything regarding anything? All right, I'm gonna stop the recording here.
Thank you, sir. Thank you, sir, for your time.